Hi everyone. In this video, I'd like to give you some hints to puzzle number 3 in your linear family of functions. So in puzzle number 3, your clues are found in the upper right hand corner. There's a point x equals 5, y equals negative 6 that sits on the line. And then there's the point x equals negative 10, y equals 1 that sits on the line. So right away, when I know it's a linear pattern and I'm giving 2 points, I'm going to find the rate of change. So we have the y minus the y, your rise, divided by the x minus the x, your run, which will be negative 6, take away 1 is negative 7, and 5 minus negative 10 is positive 15. So now I'm going to go to my building block, y minus y1 equals m parenthesis x minus x1, and I'm going to substitute in the easiest point. Mason was working over to my left and he used the point 5 comma negative 6, and I'm going to use the point negative 10 comma 1. You can use either, it will work out. So I put in my y value there and my x value over here. It would be minus a negative 10, so that would become a plus 10, and I put in my slope. And now I have to manipulate it, so I have y equals mx plus b. So the first thing I'm going to do, I just really don't like working with fractions, so I'm going to clear my fraction by multiplying 15 on both sides. So I have 15y minus 15 equals negative 7x plus 10. And then with the manipulation, distribute this negative 7. Oh, yep. And I have negative 70 and negative 7x. And then move this 15 over to the other side. So now I have 15y equals negative 7x minus 55. And I'm going to get standard form, which it wants here, by moving the x over to the left-hand side. And I have no fractions, so that works. And I'm also going to get y by itself to get it in y equals mx plus b form. So I took what I had and divided both sides by 15. It's all over 15. So the 15 applies to both the negative 7 and the negative 55. So it would be y equals negative 7 over 15x minus 55 over 15. And now I have both of my equations of the lines. A little hint when you go to do your table, I started with my easiest point, which is my y-intercept. And I know my y-intercept from my line is negative 55 over 15. And I know it has a constant rate of change. And the slope is negative 7 over 15. So it's going down by 7/15 every time. It follows a pattern. So you can see that negative 1 is 48, minus 7 is 55, minus 7 is 62. And then you have some harder ones. We have to substitute in x equals 5 into the equation, but it should work out nicely. You should get negative 6. And negative 10 works out nicely to be positive 1. And then also we can substitute in x equals 10 and get negative 125 over 15. Now you can always double check on Desmos. If we substitute in 7x plus 15y equals 55, I think, is that the correct solution? 7x plus 15y equals negative 55. Okay? Or I put in y equals negative 7 over 15 minus 55 over 15. Oh, I forgot my x. They're the same line, and I can convert this to a table, and I can double check my table values in there. Lastly, reading function notation. If you work too hard on this, that really hurts. They're giving you the x value, and oh my gosh, look at the design of this. All of these are found in the table itself. So when x is negative 10, y is 1. When x is 5, y is negative 6. And when x is 10, y is negative 125 over 15. When is the y value equal to 1? If I scroll down my table here, oh, the y value is equal to 1 when x is equal to negative 10. And then solve, set negative 10 equal to your equation, clear your fraction, and manipulate to one side, and you should end up getting 95 over 7. So those are some hints to puzzle number 3.